All right, welcome back to week 5 of our database development design course. We're going to talk about developing a data model. So this is continue on with the model, keeping in mind that when we talk about models, we're not talking about databases yet. We're still talking about in the abstract. So we use terms like class and attribute. You're going to hear me misspeak. I'm going to call them tables. I'm going to call them fields, and I'm wrong in that. And part of that is because, I work in this for a living. I don't really kind of exist in the academic viewpoint of it all. I'm teaching a class, but I'm more in the practical view world of it. But technically and correctly, when you're discussing a data model, we are talking about still the abstract. So we haven't moved on to the practical solution of actually building out a database or an application. All right. So here we are. Let's pop into the slide deck, and let's start off by getting the first thing you really want to talk about at this point is we're starting to understand a bit more about how we model data. And we really kind of want to take a breath before you get too deep into it and say to yourself, hey, let's look at the data and how the data relates to itself that we have at hand before we go too deep into the data modeling process. You want to make sure you have all the data you need. Is the data there? Is it available? Is it in a format you can use? And then another trap you want to try to avoid, and this is one I fall victim of myself all the time, is bringing in more data than you need. You're like, maybe I'll use this later. You generally don't. It becomes kind of like the junk drawer of the computer science world, where you've got a bunch of columns that no one's ever going to use, chunking up a database that it was totally unnecessary. So there's a time and a place for the big data thing. This is not it. This is the relational database. So we do want to trim away stuff we don't need as well. And when you're looking at your data model now not just the data, looking at the data model, you want to make sure that your data model works and works for a given set of assumptions and within the project scope. So what is the project? What is the problem scope? I'm sorry. What is the problem? What is the scope of the problem? And do we have assumptions? And what can the assumptions be? The assumptions can be anything from, will it work on a desktop type database thing like Access, or do we need something like SQL Server or Oracle? Is it going to store things that don't work well in a relational database? Who's going to have access to it? How are we going to block access? All these things, these assumptions that are going to come into play. So you got to make sure that your data model works for these kind of assumptions and stays within the project scope. So let's go ahead. And let's take a look at the first one here. We got a soccer club data model here. And we got a class over here to the left. And again, this is a class because this is the data model. And it's got some attributes for everything you need on a team. Team ID, name, age group, captain. And again, given the team name, it'd be easy to see all the attributes for the team. But what if you wanted to see a given age group? And the example down here in this example table shows this U12 and U space 12. Okay. As a human being, you could look at this and immediately say, yeah, Rage and Hurricanes are both in the U12 league. As a computer, you're not going to see that. That's going to see those two things. This U12 and this U12 is two completely different things. They don't exist together. So this is a problem. This is a common problem within databases. How do you keep, it happens. Well, think about addresses. How many ways can you write the word drive? I say, or street. If I say go to 100 Main Street, you can put ST, you can put STR, you could type STREET. I mean, so there's so many different ways you could just do that alone, and names, all kinds of things. So sometimes you want to try to limit the ability to mistype something by putting it in. And one way to do that at this point is to look at this age group and say, you know what, let's take this age group out and let's put it in its own class. So we go here, and that's what we did here. So now we have the age group. The name of the age group, and I don't like. I should have called this team name and name. The naming convention here I do not like. I didn't make this slide, but okay. So I would definitely call this team name, and I would call this like age name or something, group name, something. Because ambiguity is never good later on when you're trying to dig through a database. But anyway, just looking at this, what we did is we took out the age group and we put it in its own table. Again, up here, class, down here, table. Okay, so see what happens now. So U2 is only going to appear once in this table. It's got an age group ID, so it has its own primary key to link it to. then you can share it over here with the age group. So you can quickly see that Rage and Hurricanes are both 3, which is the U12. But since it's only typed in once, there's no chance that you can accidentally type in U12 twice because incorrectly in a different way because it's only used in here once. And that's a good thing. Now, how would we add in additional player details? And assuming a captor's a player on the team, how are we going to deal with that too? So let's go ahead. Let's jump ahead and let's look at the next issues. I mean, think about it for a second. What if you had a captain's team player, and how do we add additional player details? Like if we wanted, again, your phone number, email, address, things like that, the name of the player. Because again, this name is not the name of a player; it's a team name. This is not the name of a player. This is the age group name. So let's go ahead down, and we create a player class. And here we have player ID, first name, last name, phone, email, team ID. And the player plays for a team. Okay? And obviously the team would have an age group, supposedly. I would assume that each team would only exist within a single age group. I mean, that's an assumption. I believe that's the assumption being made by the relationship here. But here, notice here, there's something new. We have is a captain. So a player is a captain. So a player can exist on here twice or show up here, be referenced twice in this table because he is a team. He'll be in here as a team player or her as a team player and also as a captain ID. So it's okay to have multiple relationships between a class because that's what we're doing here. So that's how this works. So the player, you have a list of players here. So let's call it Sally. So Sally is a player for this team, the Reds. Okay? So she'd appear here, and let's say her ID was 1, so she'd appear here as a player, and with a team ID down here. So that's how that would work there. Her team ID would appear, the Reds team. But as a captain, she's also going to appear, her ID will appear down here in the captain ID for the team Reds. So every player who's on the Reds will have a link to this captain ID, which is Sally. Okay? So that's how that works there. Let's go ahead to the next. All right, so the kind of the questions you can ask when to looking at this, what we just did, we broke apart a single table into 3 classes. Now I use table and classes by accident. Is you want to say, do you want select objects based on the value of an attribute? Then you may want to introduce a class for that. Do you need to store other data about this information, such as if we want to store other data? What were we talking about there? That's back up here with the player. We want to store data about the players, so that's how we create a new class there. And are you already storing similar information? You want to use the relationship of existing between classes. And this, again, is the team captain thing here we've got going on. All right? So that's just some questions to ask yourself as you're developing a model. Let's take it another thing. Let's look at an incubator example. Now, this is, imagine you've got a building, bunch of room numbers, and a bunch of companies all co-reside in this building, and you have employees that go there. So you can have an employee that works for a company, and a company is in a room. And you could also have this connection here where the employee is going to be working in a room too, technically. So this, while not technically incorrect, is redundant. It's not necessary because as an employee for a company, I could infer what room you're in based on the company you're in. I don't need this extra relationship here. But you can have more than one path. It's not incorrect, but it's only necessary as long as it's providing different information. And believe me, this becomes more and more complex as your data models go into having dozens and sometimes even hundreds of classes. Okay. You're going to look at some traps you got to worry about here. This one's called a fan trap. All right, and we're going to the idea that you have employees who are going to be part of a division, and divisions are made up of many groups. So division could have, Division A could have groups 1, 2, 3, 4, 5, 6 in it. Division B has groups 8, 9, whatever. Okay? And the problem is when you're trying to infer something that's not intended. This fan trap is when you have too many relationships here. These are called many's, these ends here. We have too many relationships on the outside here. And let's look at this picture that kind of displays it a little better. So this is the fan trap here. So again, a division can have all these different groups. So let's just say there's only one division. Let's just say Division 1, and you have group A, B, C. So Jim belongs to Division 1, but we have no idea what group he could belong to from this. There's no way to know which group Ann belongs to from this. There's no way to infer any of this. So we're going up here. So as you can see, there's no way, the way this is set up, that I can infer the group based on this division. As opposed to when we went up here, you notice we didn't have the one-to-many on the outside. We had employee can work for a company, and we know the company's in a room. So that we can infer the employee is in a certain room based on which company he's working for or she's working for. Okay, so let's go ahead now into the chasm trap. Okay, now we have each employee can belong to at most one group. Each employee belongs to one and only one division. Divisions are made up of many groups. Can you ask the question, what division does each employee belong to? You can infer that across here. Group, bam. The issue is this 0 here. That's what the trap is, and we're going to show in the next picture. So what happens is you don't have to, an employee can belong to at most one group, does not have to belong to a group, though. You see this? This 0 means the employee doesn't have to belong to a group. So we have somebody like Ann doesn't belong to a group. So I have no idea what division Ann would be in because I don't have a group to infer her from. Like I can infer anybody who's in group A or B is in division 1. Anybody in group C is in division 2. But if she's not part of a group, she may be part of a division, just not part of a group, maybe not be required. But there's no way for me to infer it based on this data model. So we would have to try a different approach. Okay. And you also want to think about different routes between classes. Whenever there's a closed loop, check to see the same information is being stored more than once. Don't be redundant on that. Make sure you're not inferring more than you should from a route. Always look at the case when the class is related to two classes where the cardinality may have many at both outer ends, and ensure the path is available for all objects. Make sure there's a path. Again, there was no path for Ann because the group allowed her not to be part of a group. And just like there's no way to make an inference here and here. These are things we want to worry about. And sometimes it does help to do this. Sometimes when you're trying to figure out your data model, just draw something stupid like this out and say, ooh, yeah, that's a problem. That's not going to work. So, and then finally, there are situations in which you can self-infer within a single class. Let's think about you have a class of members who belong to a club, and a member needs to have a sponsor to get in. Well, the sponsors are obviously all going to be class members, but not every member has to be a sponsor. So let's say that Sally is a member. Actually, we wouldn't put it in there. Let's just say, put up here, say Sally's a member. And then I want to join, so Sally sponsors me. So I'd join, and then so up here, Sally as a member ID would come up and be my sponsor. But you notice it's 0 to many. She can sponsor many members, but as a member, maybe I don't sponsor anybody, so that would be the 0 to me. So there are cases where self-relationships do work. But keep in mind, these can be a bit convoluted and confusing, so try to use them only when you have to. All right, so that wraps up the look at week 5, developing the data model and design. I really want you to just kind of go back and think about some of the problems we solved. We solved the repeating misspelling with the U2 by creating to a different group. We were able to add additional information, and we are able to fix the captain issue by adding a second relationship between two classes. We looked at using multiple routes and showed, like in this case, it doesn't always make sense because I can infer an employee's room based through the company. Then we looked at situations where inference didn't work well, like this division to group in which we had this fan trap where we had minis on either side, and it led to this mess where there's no way for me to infer which group you belong to. And then we looked at the other side where we had this chasm trap. And again, because of this 0, because allowing the fact that somebody doesn't have to belong to a group. It left somebody to the point where we have no idea what division they can be in. So that's a broken thing too. And then finally, we looked at the idea of self relationships within a class. All right, keep this all in mind and look forward to seeing you next week. Thank you very much.